Start recording. Okay, so we're going to go over test 4 today. So test 4A, I'll go through these right quick. But this one is 1. This one, I think most people got these two correctly. X to the 8. So this is on test 1. Test 2, I think maybe, if anything, people missed the negative sign on the 1. The negative is on the outside of the parentheses. 7 plus 2, we're adding the exponents when we see stuff being multiplied. This guy, a few people missed this. We are subtracting these exponents, so this should be a 7. I can't even write it correctly. 7 minus a minus 2. Same thing here. This is like 5 minus a minus 9. So these should be going up. It's like we're adding these things since we're subtracting a negative. So this is like what, x to the 9th. This is x to the what, 14th. These, they're both a little different, but there's a few ways you can do these and a few ways you probably shouldn't do these. But what a lot of people were doing is they would flip it and they would get rid of this negative, but they would also get rid of these negatives. So you have to do these things kind of one at a time. If this is p to the 3rd, I guess we can do it this way. P to the 3rd, 2 is still up there. K to the 5th, if we flip those two things. That is one way you could do it. And then you still have to flip everything again. This is probably not the way I would do it, so I think I'm going to get flipped twice. A lot of people are only flipping those once, or trying to do two things at once or something.
But would the exponent negate those negative signs inside of the parentheses when you just multiply them together?
Yes, so that's the other way you can go about it. So this is the way that I would do it personally. I would look at this as 2 to the minus 5th, k to the positive 25 now, because we're multiplying two negatives, or p to the positive 15. And so this is probably the way that I would go about doing it. You should get the same solution either way. On this one, we have to put the 2 to the 5th on the bottom. So I need to simplify that. What is that, 32? Is that what 2 to the 5th is? Oh, horrible. Yeah, that's 32. K to the 25th. So the final solution should look something like 32, like that.
I think I must have the other test.
Okay. You might have, yeah. You might have test A.
Yeah, I didn't write it down. I forgot which one.
So this is 2 to the minus 4th, then k to the 12th, p to the 8th. You probably got the 8s and 12s and the 4th.
Is this number 2?
This is 2b.
2b.
Or not to be. No, it is 2b.
Yeah, I don't know. Oh, you're already working it out though. Okay.
Yeah.
Positive 12. Okay, let me see what I put here.
16.
But okay, so you took the negative 16 and you dropped it to the bottom.
Yes.
Right?
2 to the minus 4 becomes 2 to the positive 4 on bottom.
On the bottom, okay.
We got to flip it to make it positive.
Okay, so okay, because 2 was a positive number. Okay.
Yeah, so you can think about these things as like 2 to the 1st power if we don't see a power on it.
Mm-hmm. Okay.
Yeah, I would say B is pretty involved. It's one of the more involved ones. Each of these was worth around like 9 points. I think this one came out to 8 and this one came out to 10 when I added them together. But each little part after this is pretty much, it's 9 points straight up, I think. So this one, a lot of people just like, I don't know, they were confused on what to do or something. But if we have a molecule for carbon and the molecule is this size and there are that many molecules in a row, how this is set up is we want to figure out how long this carbon fiber is. So if we want to know the length of the carbon fiber, it's the length of a carbon times how many carbons are on that fiber. So it should be multiplication. And I wasn't trying to be tricky with that, but I think maybe it's just a word problem and it confused a lot of people. And this is from test A is the one I'm grabbing it from. So then the process to do this is hopefully you have a calculator. You're going to multiply the two numbers out in front together. So 8.25 times 4.21 will give me 34.7325. And this should be times 10. A lot of people messed up with these things. But this is like a -7 and we have to add 12. So this should be 10 to the 5th. Okay, so same thing that we did in the homework. This thing is like one too many, so we have to move it back one. So it should become something like 3.47 is probably pretty good, times 10. This one got smaller. This one needs to get one larger. And then the other thing is it said write it in both scientific and standard. Some people like forgot to convert it to standard 470. And this is what, centimeters or something? That's what it was measured in. Yeah.
Oh, this was the carbon fiber one?
Yes.
I put a decimal in my regular notation for some reason. I don't know if that's correct.
No, you can put a decimal here. That's okay. Is that what you're talking about?
I must have the other test because my regular notation was what the number I got was 34732.5 centimeters. Maybe that's the other test.
347,325. So when you multiply these two things together, you should get that 34.7325. I think that is the test. Maybe you just.
Oh, it is. Okay.
Yeah, it might have done the decimals differently.
Maybe I just extended mine more. I don't know.
Did you get
I
the
usually,
same?
yeah, I usually try to extend my decimals as much as I'm comfortable with to try to be as accurate as I can.
Yeah, okay. Yeah, so we could
I
put
don't really
that on
know.
some. Yeah, and we probably really should here, right? Because this is 3 and this is 2 and 5 and 0 if we fully expand it.
Okay, so generally we just have to go like 2 or 3 decimal points and then we're good after that.
Yeah, generally like 2 or 3 decimal places is usually pretty good.
Okay.
Because let's be honest, if I'm talking about like 3 million centimeters, I'm probably not going to care too much about like 3,000 centimeters either way. And it depends upon the context of what you're doing, obviously, right? Whether we're doing brain surgery or horseshoes, right? So it's like what, there's no really straightforward answer unless you know like the context of what you're doing, to be honest. There are like the significant figures and then like the way they do things, but that's a whole mess. I don't want to do that. Just usually get it 2 to 3 decimal places and you'll be pretty accurate in this class, I think. Okay. This other one should be pretty similar. This has got different numbers, 6.25 times 7.81. So I can do this one right quick, times 7.81. This is like 48. Times 10 to the, this is -7 is 12. It's going to give us to the 5th again. We want to move that decimal 4.88 times 10 to the 6. And then if I want to move my decimal and write it in standard 881, I guess I could do 250. You want to be really accurate, you can put in all those numbers. As long as you put in 488 and these are zeros, I would still count it correct. You're close enough. Okay. Now,
Was that 4A you just did?
I just did 3.
Oh, sorry. I thought you moved on to 4. Sorry.
No, I was still
I'm
doing.
confused.
This is 3 and what did I do last? 8.21. Yeah, it was 3 and part 4A. Test 4A. Is that what you're talking about? Sorry. This is test
No,
4A.
yeah, I was mistaken.
Okay. I got confused because now we are about to go to 4A.
No.
Problem 4A. Sorry. I think you confused me for a second. It's like 4A test or 4A problem. Distinctions. So this one is test 4A. So I kind of gave them to you in pretty much the order that we learn these things in, a little bit with these first two. Like this is factor by grouping. So you could have done this, you could have done a box. So for the first one, I could take a 4 and an x, and I believe that leaves me with x plus 3. This one I can take out a minus 3, leaves me with an x plus 3. Hopefully the same thing. Ooh. No, I did not do that right. Sorry, I can take out 2 x's there. So I can take out a 4x squared from this thing. If I multiply through, double check. So like, I hope you like checking yours because I like did this real quick and I even got it wrong, right? 4x times x gives you 4x cubed. 4x times 3 should give you 12x squared, right? So check these things when you're doing a test, right? There are checks that we can. If we get this, if you want to do factor by grouping, it should look something like that. And if you did this, you probably got like 2/3 of the credit or something like that. Because you did most of it, but there's an extra little step we have to do with this thing. So this thing is a difference of squares. So we take the square root, looks like x. What did I do?
You can pull a 9 out of that
I
first
pulled
one.
a 9. That's what I did. No one told me this. Whew. I am factoring horribly this morning, apparently. I pulled 9 out of that thing. Minus 9x. I said check it, and I already I went over this thing, and y'all saw me go over it. Okay, so even if you do this for a couple of years, you might make some mistakes. That is 4x squared minus 9. This is x plus 3, 2x plus 3, 2x minus 3. It's not like I saw this problem like 10 times already. Similar things happen with this problem, although it's like a little bit different. I could take out what, a 4x squared from that first thing? And I think I'm going to factor out x plus 4. I can take out a minus 9, and then should be left with an x plus 4. Similarly, I think this gives you x plus 4 and like a 4x squared minus 9. So I think it's just this factor is different. This factor is same sort of thing is happening on this problem. We have to factor that difference of squares. And factoring this guy, this is 3 terms. The way that we do 3 terms is by AC method. So 3 times 8 will give me 24. It's going to add to 23. I think that's going to be 1 and 24 with the 1 being negative. So 3x squared, I'm breaking that middle term apart. Minus 1x. Ooh, excuse me. Plus 24x. Ooh, subtract 8. Now I'm grouping and grouping. This looks like x, and it's going to leave me with a 3x minus 1. I can pull out 8 from this guy, and it's going to leave me with 3x minus 1. So I think this one is just the use of the AC method. Can we pull out 3x minus 1 and an x plus 8? And let's jump to this one. I think doing 2 of them at a time might be the way to do it. Diagram. So now I am back on test A. Minus 10 that adds to 9. So I think 1 and 10 are going to be our lucky numbers, with the 1 being negative. I think I'm going to shoot for the box with this thing. So a few people did the box method, and for the most part, the people doing the box method, I think they're doing probably a better job than the people not in general. Like if you're struggling with this, I like strongly suggest going with the box. It really helps with the structure. 2 and 10, I can take out 2 and an X. Between this, I can take out that -1 leading. I could take out an X here. I got to take out what, 5 plus 5? 2X minus 1, X plus 5. I can check my solutions. 2X times X gives me X squared. This gives me minus X. This gives me 10, and that gives me minus 5. Okay. This one, if you didn't do this thing first, it probably was a lot harder. But the first thing you should notice is like these are all multiples of 5. I believe I can take out a 5, and I believe also this is the thing that really will kick you in the butt. Take out an X. We have a 5X that we're starting to take out with. X squared plus, we got 6X plus. This thing you can do with the AC method. There's a few ways you can do that. AC method, you can recognize maybe it's a pattern there. But that is a perfect square. If you try to add, multiply the 6, add to 9, whew, that would be 3 and 3, right? We get plus 3 plus 3. We could break it apart into plus 3x, or you can recognize, hey, it's just 1 there, and you can also use that shortcut. There are a few ways you can do this to get from there to there, but that is a perfect square. And then the other thing, the really thing that you have to be careful with on this problem is that you bring down your constant, or not your constant, GCF that you took out at the beginning. Okay. And what about this thing? It is very similar. So instead of 5, I think we're now taking out what, 7 in an X? If we take out 7 in an X, that leaves me with an X squared. X plus 4, and I think that's also a perfect square. If we do it, I guess we can do a box right quick. We're gonna have X squared. We're gonna find it's 2 and 2 are the magic numbers. And we should be getting something like X plus 2 out of this thing. And so you look at your box, you say, I got X plus 2 plus X plus 2 out of the box. And then the other thing that you might forget is to bring that thing down after you do that. So you can do these with box AC method, 3 terms, or 4 terms, I mean. Use the AC method to make the 3 terms 4 terms, then use the box. Questions about these? I know I'm going maybe a little quick, but if you got questions, scream and shout. I don't know what to say. Holler at me. Okay, 5 A and B on part A, on test A. Someone saying something?
Nope.
This one has got 3 terms. You can do it with AC method. If not the one, you can use a shortcut if you want. Multiplying to 16, add to 10. I think that's 8 and 2, 2 and 8. So if you want to break it up into X squared plus 2X plus what, 8X plus 16, you could do that, but I'm probably not going to do that. I'm probably just going to jump straight to my factors. So if you want to factor this thing with grouping or with the box, you can, but I'm going to use that little shortcut. This is one. I can kind of just jump to those factors. So it looks like x plus 2, x plus 8. And the important thing is that this is still equal to 0. From this point, I think there's at least one person that missed this. We got an x plus 2 equals 0, x plus 8 equals 0. So you do still want to solve these things correctly. There's like at least one person that missed getting these things correctly. So in order to get x, we have to subtract 2. So this is going to be x is equal to a minus 2. This is x plus 8. This is x equals a minus 8. I think they said x equals a positive 2 or something like that. But it would be, we would have to subtract it to get it to the other side, right? And that's a really common mistake, which is why I'm like trying to highlight it a little bit. I'm not trying to pick on people. That's what it sounds like. I'm just talking about like the process, right? This looks like x plus 2, but this looks like x equals a minus 2. So these are things I'm trying to like highlight, probably for some odd reason. I don't know. Might come up later. We see this thing. Okay. 7x squared equals 56x. We want to factor this thing. What's the first step of factoring something? We have to set one side equal to 0. So the first step is always set one side equal to 0. So if you want to factor this thing, we're going to have to move this to the other side. We're going to have to subtract 56x. So I think a few people try to do some weird things with this. But for the most part, I think most people probably did this step. This thing. Now, how do we factor this? And it's really easy if you do it the correct way. It's a lot harder if you try to do it some other way we haven't learned. I don't know.
Pull out your GCF of 7.
There is a GCF here. So there's a GCF of x. So anytime there's a GCF of x, pull that thing out because it makes life oh so much easier. 7 and 56, they both have a 7 in common. And I believe if we factor that out, we get what, x minus 8? And the other thing people did. Most people got this one. Not everyone finished this other guy over here. So that is one option. This is absolutely a correct solution. But if you factor out something and it has a variable in it, there's an option that this thing could also be equal to 0 when we do our 0 product rule. So don't forget this guy. And some people did this and then they didn't finish it. It's like you have to do one more step. We still have to divide by 7. 0 divided by 7 is still 0. This is a valid solution. And again, we know what solutions are. You could go and plug this thing back in. 7 times 0 is going to equal to 56 times 0. It will make it a true statement. We can go plug it back in and see if it works. 7 times 64, is that going to be equal to 56 times 8? I hope so. It looks like all the factors are the same. 7 times 8 times 8. 7 times 8 times 8. Questions about this one, about these solving? So this is really no different than the previous problems, right? Except now we're solving. We're solving things equal to 0, and we have to do the 0 product rule. But everything else, the factoring is still there. Factoring is still there. Okay. Ooh. Maybe I don't have to go quite so quick. X squared plus 9x plus 14. So again, this is 3 times. We're going to do the AC method. We're going to look for something that multiplies to 14, adds to 9. I think 2 and 7 are probably those numbers. with both of them being positive. So if you wanted to, you can break this thing up. Ooh, I'm crunching into my numbers over there. You can break this thing up if you want. That's absolutely one way you can do it. You can go put this in a box. You can try to factor by grouping. That's a lot of work. And I'm kind of lazy. So let's do x plus 2, x plus 7. It's a shortcut. We can save a little bit of time. If you can recognize it, you can do it. If not, you're still doing good math. I'm still going to be happy. I don't really care. As long as you get it, just get everything correct. It's so much easier to grade. That's all I'm asking. Not too difficult, right? Y'all can do it. X plus 2 equals 0. X plus 7 equals 0 are the two things I'm getting out of here from my zero product rule. This x plus 2 is going to give me a minus 2 when I move it over. This x plus 7 is going to give me minus 7 when I move it over. So I get a negative 2, I get a negative 7 are my two solutions. Okay, this one should look pretty similar. Like I said in the previous test, if we have what? 7x squared equals 42, we're going to want to move that 42 over to set one side equal to 0. So 7x squared minus 42x is equal to 0. And like the previous one, if we pull out that GCF, it will make life a lot easier. So this looks like 7x squared. Sorry. 7x, and then I do what? X minus 6 is equal to 0. And the same thing with the previous problem. There's this x minus 6 equals 0. And then there's this thing over here that some people missed. There's also the option that x would be 0 or x would be 6. Are there any questions over this one, over the approach, how this thing's done? Okay. Let's get on. We got one final one. This one. This one, I think most people, we're kind of on the right path with part A. We see f of x equals 3x squared plus 8x, and it says f of x equals 35. And so what we want to do is we want to take our equation, and we want to know where this equation is equal to 35. Where is our function equal to that value of 35? And so most of you set it up correctly. I think most of you were in the right process of saying, hey, I have to subtract 35 over. Have to factor this thing with what? AC method. So this isn't the prettiest problem. But we should be able to do it. 3 times what? Minus 35. We're looking at a minus 105 that adds to 8. I'm thinking 105, and I'm thinking 5, and 21. 7 and 15, I think was the next thing I had on my list. So it is kind of a big number, but I think our solution comes pretty quick. It's like the third factor that if you're typing into your calculator, it shouldn't take you too much time if you got technology. Might take you a little more time if you don't. And if we want to make it positive 8, it's got to be a negative 7 and a positive 15. So we're looking at this thing 3x squared plus 8x minus 35. Looks like x squared minus 7x plus 15x minus 35. And it should be equal to 0, and I'm running out of paper over there. So we're doing this with 4 terms one way or another. I guess I'll throw it into a box. 3x squared minus 7x plus 15x minus 35. Between 3 and 15, I can take out 3 and an x. Here, I got to take out a minus 7. Here, I can take out an x. Here, I can take out a positive 5. So what I believe this is giving me is 3x minus 7, and I have an x plus 5, and this is equal to 0. Ooh, and this is another common mistake that happens here sometimes. 3x minus 7 is equal to 0, and x plus 5 is equal to 0. So this one is x is equal to minus 5. This one, there's a real common mistake people make. They see something like 3x equals 7, and then they will tell me it is 3/7. That is not 3/7. That is 7/3. But make sure you divide things in the right order. A lot of times people flip that. Okay. I should have asked you what point does this give you. That would have been like maybe more of a leading question. So what point are we getting from these two things? And let me go back up to the problem. And let me throw my solution just on here. 7/3, and x is equal to minus 5. And if I wanted the point, what point would you give me for part A?
Like 7/3. Sorry, 7/3 to 35.
35 is my y. So this is 2 points. Are those x-intercepts?
Yes. Okay, the X ones.
What is an x-intercept?
Oh shit, my bad. No, an X
Yeah,
intercept.
yeah, those are not
7/3
x-intercepts.
0. So 7/3 0 and -5 0. I guess.
That's not what these are, though. That 35 is correct.
Right.
Yeah. So this is the thing that a lot of people missed, and it's the same on the both tests. So y'all got your solution for part A. So in the other test, it's going to look a little bit different. But you got the solution. This is a completely separate sort of problem happening over here. And y'all were trying to like draw or carry the solution from the first part to the second part. It really should be separate. So what are the x-intercepts? And like someone even put it, right? X-intercepts. Y equals 0. F of x equals 0. And like I had one person put this and they didn't do that. They still grabbed those numbers from the previous section. I think there's one person that set it up to solve it right, and then they didn't solve it right. So this one was not a friendly problem to this class. It was like I don't know. So going back, my f of x is this thing that looks like 3x squared plus 8x. That's my f of x. I want to know where this thing is 0. So this thing, I hope, does not take you too long to factor it. Because what's the first step of factoring? We look for a
GCF.
Mm-hmm. And my GCF here is a single x. So I get something like 3x plus 8. One of my solutions is x equals 0. Another one of my solutions is where this thing is equal to 0. I'm going to subtract the 8 over. I'm going to divide by 3. So I should get x equals 0, x equals minus 8/3. And if you did that, you would get most of it correct. It really should be in the format, what, 0, 0, and minus 8/3, comma 0. So they ask for intercepts, it really should be the points. So I know you plugged in this value for y and then you did a bunch of work and then probably forgot what you're doing, right? Same thing with this. You gotta remember what your y is to begin with, right? And that's, I don't know if maybe I just primed y'all to get this second part wrong or something by making you solve this first part. I'm not sure. But it wasn't intentional if that's what happened. This one is a little bit different, but it looks pretty similar. 3x squared plus 4x is equal to what? 32. We subtract 32 over 3x squared plus 4x minus 32 is equal to 0. This thing is three terms. We want to do AC method. A times C is a minus 96. And it's got to add to 4. 96, 2, and what do I have on paper? 8 and 12, I think, is where it's going to get hit. 4 and 24 is also on there. So I think 8 and 12 are the magic numbers, with our 8 being negative. And if I'm being honest, I think most of you have at least learned something, even if you didn't do good on the test. It seems like most of y'all were at least getting some of those magic numbers correct. Y'all were hitting those things. So I know things may not always be what you want them to be, but not 4x anymore. 3x squared, and I want to do minus 8x, and I want to do plus 12x, and a minus 32 as well. So this is what my problem looks like when I split up that middle term. I can pull out what here in x. Minus 8. I can pull out here a 4. 3x minus 8. And I still have equals 0, even though I don't have paper to write it. So let me maybe do 3x minus 8, and I have an x plus 4. And this is equal to 0. Either what, x plus 4 is 0, or this 3x minus 8 is 0. So I think this thing, when I add it over, is going to give me 3x is 8. So x is 8/3. This is x is a minus 4. And I know I did it once with one problem, but just to re-emphasize, I want to look at this thing. I got a minus 4 comma something, and I have an 8/3 comma something. What is my correlating y value to these things?
It was 32, right?
Yeah, it was 32 that I plugged in originally. So these things should be the point minus 4 comma 32 8/3 comma 32. And the last one on here. What are my x-intercepts? So go back, look at this thing. So how do I solve my x-intercepts on this guy? I take 3x squared plus 4x, and what am I doing with it?
Equals 0.
Yeah, equals 0. And so this is very kind of similar. There's not a lot I can take out, but I can take out an x and factor out an x. It will leave me with something like 3x plus 4. This is equal to 0. So either my x is 0 or my 3x plus 4 is 0. If this thing is 0, 3x is a minus 4, and x is a minus 4/3. And so if you solved for these two numbers, you did most of the work. There's one sort of thing you should do. You should put this in the correct format. This one is 0, 0. This one is minus 4/3, 0. Did you know what this is? This is a mouth, so you can tell your name. He's staring at you there. The origin. Are there any questions over the stuff we've done? We went through them pretty quick.
Good.
But I think we did get through them all. All right. Do 648. Yeah, let's do that. 648x to the 11th versus key root of 648 x to the 11th. Just a quick recap
There we
over
go.
these two things.
Is this the test still or something else?
This is something else, just to
Oh.
make sure we still know what we're doing. Quick little recap. Call this part A and part B, I guess.
Mhm.
I'll even factor it for you if you want. 648 is
That'd be nice.
2 times 2 times 2. So there's 3 2s and there's 4 3s, I believe, in there. 2 to the 3rd, 3 to the 4th. So if there's not a number on the radical, what do we assume it is? I guess let's get that out of the way.
Square
We
root.
assume it's square or it's a 2.
I usually do the exponent or the what do you call the variable first, because that should be easier. So I just take the x11 and I make it x10 times x. And then I just divide x10 by 2.
Yeah.
So that should be simple enough.
Yeah.
And then you can start with the numbers. X. Yeah, and then just set that aside. X48. Okay, let me try. Let me see if I can this will work. $648. Yeah, it's a pretty big number.
Yeah, there's multiple ways to do this one too.
10.
I did tell you how to break it apart, so hopefully. Except there's 3 2s and 4 3s, right?
Let's see here.
And if we don't see it, we can think of this thing as a square. Okay, so what am I circling on this thing? How many groups of 2s are there that can circle?
3.
What? This is
Yeah,
square
so
root.
group of 2. Oh shit, my bad. Thought you were asking for like something else.
So I'm looking for what? If it's a square root, I'm looking for groups of how many?
2.
I'm looking for groups of 2. So I should be able to get what? One group of 2 out of there?
Mm-hmm.
And one's left over. I can pull out what? A 3 and a 3. And when I pull them out, like what's the operation that's happening? Is that a maybe? I got 2, and how's that connecting? This is multiplication. It's still multiplication, right? It's 2 times 3 times 3 that I'm doing out here. So 2 come out as 1. And then he talked a little bit about this, but dividing what 11 by 2 is essentially what we're doing. We'll get 5 with the remainder of 1. So we get 2 times 2 times 3 on the outside. On the inside, I have, well, on the outside, I also have an x to the 5th is what you're saying. And I have an x to the 1 remaining on the inside. And anything else I'm missing here?
2.
2. Still got a 2 by himself on the inside that did not get circled. Now, this is pretty much, we got everything out that needs to get out. We need to clean this up a little bit. 2 times 3 is 6 times another 3 is what, 18? And I'm probably not going to write that one exponent on my x, right? You can do 18 squared times 2, see if that gives you back to 648. So if you notice certain patterns, you might be able to check your solution a little bit. 5 times 2 plus 1 gives us back the 11. So there are certain patterns that are kind of recurring here, but that's also coming from someone that's looked at these for years and years. So I don't know if they're super obvious, right? But it might take you a couple of years.
Oh.
How many of those 2s am I circling?
Just one group of 2.
Yeah, so I'm circling a group, but how big is the group?
Group of 3.
Group of 3. So I have one group of 2s, and I should have one group of 3s that I'm able to circle. So these things come out. And they come out as 1. So this is 2, this is 3. Root. And the thing that I have left inside is a 3. The other thing I'm thinking about is 11 divided by 3. It's going to give me 3 with the remainder of 2. So if I want to put my x's, what are the powers on my x's here? This one should be to the power of 3, and this one has a remainder of
2.
2. You can also do a bit of a visual check. If you do 3 times 3 plus 2, it should give you back to that thing. Okay, so there's a little bit of cleaning. 2 times 3 gives me 6x to the third. Cube root of what? 3x squared. And I talked a little bit about it in the notes, but like when I do square roots, how big of a power can I have underneath the root remaining?
1.
I can have 1. If it becomes a square, if it becomes anything over 1, I can pull it out, right? What about when we get to cube roots? How big can it be under the square?
Under the radical.
Yeah,
up-
sorry. how big
But-
how big can the exponent be under this radical?
2, second power.
2 is the highest power it can be. It gets to be anything over 2, like 3, we can start pulling more out. Yep.
So what was the solution for the last one?
This is it. 6x to the third cube root of 3x squared.
No, of the previous.
This one?
Yeah. Just checking.
18x to the fifth
Yeah.
square
Sorry.
root of 2x. Okay. We are a little bit early, but we did go through 2 tests and we did a little bit of a review. Anything else that anybody has any questions on? I think that's pretty good.